Oh, I think we forgot to finish the part A. In part A, we asked, let me check, composition of solute and extract, and we don't know what's, if we need to answer the fraction of acetone extracted, we need to know what is in E1 and what is in R1. So we didn't calculate these two values, what is E1 and what is R1. Yeah, so we know 1800 kgs goes inside. So we have extract and then we have raffinate. So we have the fraction of solute in the extract side, so that's nothing but 0.302, and we have the fraction of solute on the raffinate side, which is nothing but 0.236. So we need to calculate E1 and R1. So what's that? So we already did some mass balance calculations for this one. If not, check the part 1 of lecture 5. So we have this expression E1 by M1. We derived this one, x1 minus x1 minus y1 minus x1. So let me check which equation is that. I calculated 2 days ago. Okay, that's equation 7. Equation 7. You have to check, it's in page number 153 of my notes. So E1 by M1. So I think we have all these values. We know x1, we have x1, we calculated just now. We calculated y1, we calculated x1 just now. We know what is M1. M1 is feed plus solvent. So E1 is by M1 is like F plus solvent. So I think we calculated a few minutes ago from equation 1. So this point. So we know M1 is 1800 kg. So E1 is by 1800. That's equal to, so this is equal to xm1 we already calculated. xm1 is what's the value? Is this one 0.2756. (0.2756) minus, then what is our x1 value? X1 value just now we calculated 0.236, which is here, x1, and then y1 we calculated just now, I think, yeah, this one 0.302. So 0.302 minus same x1 is 0.236. So from this one we can calculate our E1. What is our E1 value? So let me calculate using the calculator. So what is this value? So I got a value of E1 by 1800, that's equal to 0.6. So therefore E1 is equal to 0.6 multiplied by 1800. So E1 is equal to 1080. So that's the value I got. So this should be in kilograms. So and we know that E1 plus R1 should be equal to M1. So this should be equal to F plus S1. So we know M1 is equal to 1800 kilograms. So therefore R1 should be equal to 1800 minus 1080 kg. So what will be that value? So that should be equal to 1800 minus this value. So it's 720. R1 is equal to 720 kilograms. I hope this is perfect. So let me check the question again. So we know now everything about extract side and raffinate side. So we know what's the mass in the extract. So extract is 1080 kgs, 80 kilograms, and then and the raffinate is 720 kilograms, that add up to 1800 kg. So that satisfy our law of conservation of mass. So 800 kg goes in and then 1800 kg comes out. So this is fine. And if you go to part B of our question, or sorry, part A, still we need to calculate the fraction of acetone extracted. We need to calculate the fraction of acetone extracted. So how to do that? So fraction of acetone extracted. Yeah? Oh, this problem is a nightmare. Yeah? I have to cut and record again and again because my tab is getting paused for every 5 minutes. I don't know why. So let me calculate it. This problem is in fact very easy. If you solve this problem one time, it takes exactly 5 minutes to solve the entire problem. But since you are going to learn it for the first time, I'm going it a bit slow. If you know to use Excel sheet, it's very easy to plot x, and y for the raffinate side, for the extract side, and then connecting your identifying feed point is extremely easy. Solvent point is very easy, just connect them, and then you do the simple mass balance calculation, calculate your xm1 value, and then draw a horizontal line. So that should correspond to the fraction of solute in your mixture, and that from the mixing point we can draw the tie line. To generate tie line, it will take a bit of time. Other than that, this problem is extremely easy. Like fraction of acetone extracted, for example, this is like a very easy to calculate. This is something like stating the obvious. We already calculated, for example, E1. So that's our extract. So 1080 kilograms, and then the fraction of your solute in that extract is around 0.302. We calculated this one, we obtained from our tie line. So mass of acetone in the feed, we know that one. So mass of acetone in the feed. So what is that? So we know is 1000 kgs. So that's our feed solution. And then in that feed solution, 50% is our acetone. So what is that? So multiplied by 0.5. So that should be equal to 500 kilograms. So this is the initial amount of acetone that enters our extraction unit, F, and then your solvent, your raffinate, your extract. So we have 1000 kgs. So 0.5 mass fraction, or 50% is your acetone, and in the raffinate side we have 1800 kilograms. Out of that, 0.30% or 30.2 weight percentage. So that's our fraction of acetone on the on the extract side. So what I asked is like, what's the fraction of acetone extracted? So how much acetone we extract from the feed side to your extract side? So that's the question. So, and we also don't forget, if you go back to your question, solvent also contains 0.5% of your solvent. So what is that? Your solvent is 800 kilograms. So how much acetone is that? So 800 multiplied by 0.0005. So that should be equal to 4 kilograms, I think. So 4 kilograms of acetone. Yeah. So what we are going to calculate is the net amount of acetone extracted. So net amount of acetone extracted. So that should be equal to, so we know the amount of acetone we have it in the extract. So that will be, so that net amount of extracted will be equal to the mass of acetone in the extract minus the mass of acetone which is already in the solvent which we used, So mass of acetone in the extract is very easy to calculate. So your total extract mass is 108 kilograms. Out of that, the weight fraction of your solute is 0.302. So the weight of acetone in extract is equal to 1080 multiplied by 0.302. Let me calculate. This is equal to 326.12 kilograms. So that's the weight of acetone in the extract. And then, okay, let me calculate it. 1008. So that's the acetone we extracted. So if we go back to here, the mass of acetone which is already in the solvent, so with that already enters with the feed solution, is a 4 kilograms. So the net amount of acetone extracted we can calculate from this one. So the net amount of extract, amount of solvent, sorry, next amount of solute extracted, in this case acetone, net amount of this acetone extracted from the feed solution will be equal to 326.12 kg minus 4 kgs. So I hope you all can follow this one. But imagine if we started our experiment from a pure solvent that contains no solute. So the net amount of acetone in the extract will be equal to this number, yeah, because so whatever the mass that we see, that comes during the extraction process. But in this case, the total mass which is here, this is sum of the mass that we really extracted using our solvent, plus our solvent already contains a bit of our acetone. So the net mass will be equal to this minus 4 equal to 322.16 kilograms. So what is this? The net amount of acetone in the net amount of acetone, or the amount of acetone extracted using the solvent. So that's complete our part A of your question. So what is part B? In part B, what I asked is, let me check the question. What I asked. Part B is calculate the amount of solvent required. Required what? If 90% of acetone is to be removed. Yeah? So this is a really cool engineering question. So what I asked is like, you started from a feed solution that contains 50% acetone, and we added 800 kilograms, and we started with 1000 kilogram of our feed solution, and now we know using our the the phase separation line and the ternary diagram, we calculated how much percentage we can get in the extract side, how many percentage of solute you can get it on the raffinate side. But now it's a bit more tricky question. I have some objective. I want to remove 90 percentage of the acetone from my feed solution, and for that how much solvent do I need? So that's a very tough question to answer. So let us try to answer this question. So for this part of the problem, what we asked is the amount of solvent required. So 90 percentage of acetone is to be removed. So what's the problem here? What I asked is like so we know this prawn like F plus S due to M1. We also know the other type of expression SYS is equal to M1 x M1, which is equal to E1 Y1 plus R1 X1. I'm asking you what will be the amount of solvent that we need if we manage to remove 90 percentage of the solvent in the feed. So that's what we are going to calculate. So if you look at our problem, so what we have is like we have 1000 kg that goes in, 800 kg of your solvent, and then what we got is like a 50 percentage is acetones, which means 500 kg is acetone. And from this we already calculated E1 Y1 R1 X1 for this problem. So what we calculated, the amount of acetone extracted. So amount of acetone extracted, we calculated around 322.16 kg. If we come back to this page, so for this part of the problem, what we need is we have to calculate the amount of solvent need that we require if we have to remove 90 percentage of the acetone from the feed solution. So let's write this equation, F plus S, that's M1. So this is our equation 1, and then we have other equation Fxf plus Sys is equal to M1 xm1. We already calculated this value, xm1 E1 Y1 plus R1 X1. So we used these two expressions based on our initial conditions and also based on our solvent purity. Yeah, so and then the new question is what will be this value, yes value. So what will be the solvent requirement if we have to remove 90 percentage of the solute in the feed solution. So I will tell what we did. So we have 800 kg of our solvent, 1000 kg of our feed. Out of that 50 percentage is acetone, which means 500 kg of acetone, and then we get our E1. Okay, let's call this as R1 X1, and then from solvent we get E1 Y1 R1 X1, and then V1 E1 Y1. So this is our extract, that's our raffinate, and so on. And just now we calculated for this set of initial conditions, like your solvent contains 0.5 percentage of acetone. If that's the case, we found that the acetone that we can extract extract is 322.16 kg. Yeah, so 322.16 kg. So what does that mean? So the fraction of acetone extracted, or we can say removed from the feed solution via extraction is, so we know the starting material 1000 kg contains 500 kg, so but we actually removed 322.16 kg. So the fraction the amount we extracted is this value, 322.16 divided by 500 multiplied by 100. So this value should be equal to, let's calculate. I know this is a slightly taking extra bit of time, but it's okay. 322.16. The thing is, we should learn these things, yeah. So there is no point in doing things fast and not learning anything. So this should be 64.43%. So what does this mean? So with the starting material of 1000 kg, 50% acetone in the feed, with 800 kg of solvent that contain 0.5% of your solute, we managed to remove or extract 64.43% in the extract side. So the question is, now the new question is, we have this value, we say 90% we removed to remove 90% of acetone from the feed solution that contains 50% acetone. So what will be the amount of solvent that we need? So let's put the ys value. Let's assume we are using the same solvent. Ys is equal to 0.5% and so on. So we have to do a lot of calculations to do that. But before that, we have to assume few things. So let's assume you have some feed, you have some solvent, and then let's assume in the raffinate side, we have only the solvent and no carrier liquid. So carrier liquid plus and solvent are completely immiscible. So this is the first assumption we make. So that will make our life a bit easier. So now we can go on to the problem. So feed contains 1000 kg. So out of that 500 kg is acetone. So this is your weight fraction is xf is equal to 0.5, and then your extract should contain 90% of your feed solution, this one. So 90% of your acetone, so 90% of your feed, so which means that should be equal to, so what will be the concentration of your feed? So let's, okay, we have also our solvent side, and then we also have our raffinate side. So out of 500 kg of acetone, in feed. If we remove 90 percentage, so that will be equal to 500 plus 90 by 100, that will be 450 kg, I think. Yeah, this will be 450 kg. So this 450 kg will go to your E1, which will be your to your extract side, and your 50 kg will come to your raffinate side. So let's do the mass balance for raffinate. So raffinate should contain definitely 50 kg of your acetone, and then since we are already and then the feed solution remaining percentage is 50 kg of water. So at equilibrium, let's assume after the 50 percentage of acetone, so 90 percentage goes to your extract side and the remaining 10% come to raffinate side. So this raffinate side will also contain 500 kg of your carrier liquid. So this will be nothing but water. So the total mass of raffinate will be 50 kg plus 500 kg of water. So in total this will be equal to 550 kg. So R is 550 kilograms. And then now, so if you want, we can calculate the fraction of acetone in the raffinate. So let's call it as x1. So we know the fraction of acetone is 50 kg and the total weight of water is 550. So the x1, the fraction of solute in R should be equal to 50 divided by total mass 50 plus 550, that should be equal to 0.09. Let me calculate it. What's this value? 0.909, something like that. Yeah. So that will be our x1 value, and then how to get the y1 value? So the corresponding y1. So for that you have to plot. You have to plot. In the Excel sheet I gave you the value of XA, XB and XC, YA, YB and YC. So you have to plot. This is your solute in raffinate side, and this is your solute on the extract side. So what we need is we have to plot XC versus YC. So this should be in the x-axis, YC should be on the y-axis. So you will get some curve like that, x and y, XC versus YC. So this is XC is equal to YC line, but your actual equilibrium data will be something like that, somewhere like that. So let me plot it on the Excel sheet for you, so that may be a bit easy for you. So we need that graph to calculate the corresponding y1. If we know so let me go to the Excel sheet. That might solve this problem a bit easy. If you come to this, if you look at this one, the Excel sheet, so this is your mass fraction of acetone in the raffinate side. So this is the mass fraction of your acetone on the extract side. So what this one gives, so if you plot xc, the mass fraction of your acetone in the raffinate side, mass fraction of your acetone in the extract side, if you plot these two values, we will get a relationship between the mass fraction of this same compound but in the different side, extract and the raffinate side. So let me plot it. Let me plot it, and then I can also plot x is equal to y line. So it's better you use graph sheet, yeah, so that will save your time, believe me. So what is this line? This red line is nothing but it's just for my convenience I marked it, right? So this is like a y is equal to x line. So 1, if x is equal to 1, y is equal to 1. If x is equal to 0.8, y is equal to 0.8. X is equal to 0.4, y is equal to 0.4. So just for reference, and then this is our actual data. So this is the relationship between xc versus yc. So maybe I make it a bit clear here. So this is nothing but our xc, and what we have here is yc. So this is your solute fraction in the extract side. This is our solute fraction in the raffinate side. So if we know the solute fraction in the raffinate side, we can calculate. You just draw a line and then you come to the left side, and then we can get the solute fraction in the extract side. If we know the solute fraction in the extract side, we can, it's very simple, yeah, like I know you all know to do this anyway. I'll just show you. So if we have, say 0.4 is the solute fraction in the raffinate side, you draw a line, and then and this line will goes here. So this will be, so this point will be the solute fraction in the extract side, sorry. So if we come back to the problem here, and just now we calculated x1 is equal to 0.909, yeah. So we calculated this value. So if we know x1 in this graph, we can calculate, go to 0.909, put a line, and then come back. So what will be the corresponding y1? So let's do that. So let's check. So 0.909 is somewhere here. Okay, this value is a bit it's not correct. I think no, I think this value is not 0.909. This value looks very high value. It should be 0.0909, 0.0909. Okay, this value should be 0.0909, 0.0909. So if we come back to this graph here, so this is our graph. So in this graph we have to locate where is our 0.909. so that will be somewhere around here near to the point 1 line. So draw a straight line arrow here and then another line from there to here. So it will cut around 0.10 somewhere. So your y1 value will be 0.1 0.101 somewhere around this point. So what we have, if we go back to this graph, so now we have what's the amount of x1 which is in the raffinate side, and then we also calculate the y1 value which is on the extract side. So that will be equal to 0.101, and then we also calculated R is equal to 550 kgs. So I think everything looks fine to me so far. So what we need to calculate now is we need to calculate the amount of solvent. So amount of solvent required to achieve 90% separation. So that's what we need at the moment. So let me calculate this. So the amount of solvent. So let's go back to the mass balance expression. Fxf S1 ys is equal to E1 y1 plus R1 x1. So we know feed is 1000 and then xf is 0.5 plus this is something that we need to find. S1 ys is ys is how much? Is 0.5 percentage, so it will be 0.0005 0.005, which is equal to, and then we have our E1 in E1, and then we have y1 plus R1 x1. So we know R1 value is 550, and then x1 value is just now we calculated 0.0909. So what value is missing at the moment? So we also calculated y1. Y1 is nothing but, here we calculated this value. Y1 is equal to 0.101. So still we don't have E1. So we know that another formula, F plus S1 is equal to, F plus S1 is equal to E1 plus R1. So F1, so E1 must be equal to F plus S1 minus R1 or so what is this feed? Feed is our 1000 plus S1 we don't know minus R1 is we calculated 550. So E1 should be equal to 450 no, F plus S is equal to E1 plus R1. So this value is correct. So let me check the equation one time. I don't want to do any mistake. Let me check this one more time. F plus S1 is equal to E1 plus R1. So E1 will be equal to F plus S1 minus R1. So F is nothing but 1000 plus S1 minus R1 we calculated 550. So E1 must be equal to 1000 minus 550, that should be 450 plus S1. So hope this is correct. Let me check one time. F plus S1 is equal to E1 plus R1. Yeah, I think this value is correct. So now we can, let's call this as equation A, and then let's call this as equation B. So substitute A in B. So let's calculate Fx of. So let me write it again. E1 y1 plus R1 x1. So F is 1000 multiplied by 0.5 plus S1 is 800. No, S1 we need to find for 90% removal of acetone, multiplied by 0.005. That should be equal to E1 we calculated just now, 450 plus S1. 450 plus S1 plus R1, what is that value? R1 should be equal to 550 multiplied by X1 we calculated just now. Oh sorry, and also we also need to multiply by Y1 here. So multiplied by, what is Y1? Y1 value is 0.101 plus 550 multiplied by X1 value is 0.0909. So hope everything looks fine to me at the moment. Yeah, from this we can calculate. So 5000, so take 10 plus 0.005 S1 is equal to 450 multiplied by 0.101. Let me calculate it. 2450 multiplied by 0.101. It should be equal to 45.45 plus 0.101 S1 equal to 550 multiplied by 0.0909. So 49.995. So let's do this. 500 minus 49.995. Hope I'm not doing any mistake here. Minus 45.45. That should be equal to 0.101 S1 plus minus 0.005 S1. So what will be that value? 0.101 minus 0.005. So this is like 0.096 S1. In the other side equal to 500 minus 49.95 minus 45.45. So that's equal to 404.55. So therefore S1 is equal to 404.55 divided by 0.096. So that will be equal to 4214 4214 kilogram of solvent. So one thing you can understand from this, if you go back to this problem where we started, so we have so to achieve how many percentage? Oh my god, where is that? Yeah, it's here. So to achieve 64.43 percentage of acetone removal from your feed, we need only 800 kg of your solvent. But to remove 90 percentage, we needed a massive number, 4214 so almost 4000 kilograms. Yeah, so this is the one problem with the, so this is something that shows the limitations of your liquid extraction. Yeah, so this is our xc versus yc. So when the amount of solute, so this is our, so what is this? X is, so when we are coming closer to this area, so when, if you need to remove more and more solute from the feed solution, then the requirement for the solvent is going to be higher and higher. Yeah, so that's the meaning of this one. So that's why people go for no, still it doesn't matter how many stages of extraction, but that's the take home message you have to know. So first, to remove 63 percentage roughly, we need 63 percentage of acetone from feed. We need only 800 kg, but from 63 to remove 90 percentage we need a massive amount of our solvent. So I hope you all understand up to this point. I think we calculated everything, we solved this problem. So I thought to solve 2 more problems. I think this video is going to be like 1 hour or maybe even more. I recorded it into several patches. Yeah, so I record something on the paper tube and something on the what, using Panaptot on the Excel sheet. So I have to cut, edit and then put them together so that the information will flow without any problem. Yeah, so thanks for listening. I'm sorry for such a long video, but obviously you know how to design a liquid extraction unit. Take some extra time to learn this problem, but I know you will solve it. So thanks for listening.